Welcome to this lesson on linear time-invariant systems, also known as LTI systems. Today, we'll analyze whether two given systems are LTI or not. The systems we'll analyze are system alpha, y of n equals -2 times x of -n, and system beta, y of t equals 2 times x of t minus 1 plus 1. Before we dive into our analysis, let's first understand what makes a system LTI. A system is linear time-invariant if it satisfies two properties, linearity and time-invariance. For linearity, the system must satisfy two conditions, superposition and homogeneity. Superposition means that if input x1 produces output y1 and input x2 produces output y2, then the input x1 plus x2 must produce the output y1 plus y2. Homogeneity means that if input x produces output y, then the input alpha times x must produce the output alpha times y, where alpha is any constant. For time invariance, if we shift the input in time, the output should also shift by the same amount, with no other changes. Now let's analyze system alpha, y of n equals -2 times x of -n. First, let's check if the system is linear. For homogeneity, if the input is scaled by a constant a, the output becomes -2 times a times x of -n, which is a times the original output. So homogeneity is satisfied. For superposition, if we have two inputs x1 and x2, the output for their sum would be -2 times the sum of x1 and x2 at -n, which equals the sum of the individual outputs. So superposition is also satisfied. Therefore, system alpha is linear. Next, let's check if system alpha is time invariant. For time invariance, we need to check if a shift in the input results in the same shift in the output, with no other changes. Let's say the original input is x of n, which gives the output y of n equals -2 times x of -n. Now, if we shift the input to x of n minus n naught, the new output becomes y prime of n equals -2 times x of -n minus n naught. But for time invariance, the shifted output should be y of n minus n naught, which equals -2 times x of -n plus n naught. Comparing these two expressions, we see that they are not equal. The shifted input gives an output with the time reversal of the shift, not the shift itself. Therefore, system alpha is not time invariant. Since system alpha is linear but not time invariant, it is not an LTI system. Let's visualize why system alpha is not time invariant with a simple example. Consider an input signal x of n that looks like this. The system reverses it in time and scales it by -2, giving us this output y of n. Now, if we shift the input by 2 units to the right, we get this new input signal. The system again reverses this in time and scales it, giving us this actual output. But if the system were time invariant, the output should have been a simple shift of the original output, which would look like this. Comparing the two, we see they are not the same. This confirms that system alpha is not time invariant. Now let's analyze system beta, y of t equals 2 times x of t minus 1 plus 1. First, let's check if this system is linear. For homogeneity, if the input is scaled by a constant a, the output becomes 2 times a times x of t minus 1 plus 1, which is not equal to a times the original output due to the constant term plus 1. Let's calculate this. If we scale the input by a, the output becomes 2 times a times x of t minus 1 plus 1, while a times the original output would be a times 2 times x of t minus 1 plus 1, which equals 2 times a times x of t minus 1 plus a. These are only equal if a is 1, which means homogeneity is not satisfied. Since homogeneity is not satisfied, system beta is not linear. Since linearity is a requirement for an LTI system, we can already conclude that system beta is not an LTI system. For completeness, let's also check if system beta is time invariant, even though we already know it's not an LTI system. For time invariance, we need to check if a shift in the input results in the same shift in the output. Let's say the original input is x of t, which gives the output y of t equals 2 times x of t minus 1 plus 1. Now, if we shift the input to x of t minus tau, the new output becomes y prime of t equals 2 times x of t minus tau minus 1 plus 1, which equals 2 times x of t minus 1 minus tau plus 1. For time invariance, the shifted output should be y of t minus tau, which equals 2 times x of t minus tau minus 1 plus 1. Comparing these two expressions, we see that they are equal. Therefore, system beta is time invariant. However, since system beta is not linear, it is still not an LTI system. Let's visualize why system beta is not linear with a simple example. Consider an input signal x of t that looks like this. The system shifts it by 1 unit, scales it by 2, and adds 1, giving us this output y of t. Now, if we scale the input by a factor of 2, we get this new input signal. The system again shifts, scales, and adds 1, giving us this actual output. But if the system were linear, the output should have been a simple scaling of the original output, which would look like this. Comparing the two, we see they are not the same. This confirms that system beta is not linear due to the constant term +1. In summary, we've analyzed two systems. System alpha, which is linear but not time invariant, and thus not an LTI system. System beta, which is time invariant but not linear, and thus also not an LTI system. Remember, for a system to be LTI, it must satisfy both linearity and time invariance. If it fails either test, it is not an LTI system. Thank you for watching this lesson on linear time invariant systems.